So just for simplicity, we'll stay sitting here, but we're going to hand over the chair to Elke Weber of Princeton University, who will chair the next panel, and the speakers are at that end of the table, and then in the coffee break, we'll rearrange ourselves. So, okay. Elke.
Thank you so much. And thank you also for introducing us really to the richness of issues related to our survival on this planet. I think what we're trying to add now in our session is a perspective from the scientists. And we have a real scientist, and we have a social scientist.
Excuse me, I'm a real scientist too, and I'm both a natural and a social scientist,
right,
so there.
That's right, which is a perfect mix. So maybe I will hold my remarks until we've heard from our two panelists, and we go in the order in which we sit. So I was told that they need no introduction, and I completely agree. And so we'll start with Rob.
So tell me if my voice drops. Please remind me. I don't want you to tell me at the end that you didn't hear me, and I'm
Would you like the microphone, Rob, or you
tempted.
can speak standing up? That would be fine.
Is that live too? Well, then perhaps I should. Perhaps I should.
Is that live? I think so. This one. Yeah, that one. Is that live?
Is that live?
Yeah, it's good.
Okay, well, that's good. To see you better. Among the many reasons that I'm excited to be here is to be with Robert J. Lister. Robert is a hero of mine. We worked together in creating an event at Yale on March 4th, 1969, which dealt with the obligations of scientists in relationship to the military. It was part of a day called the Scientist Strike that was organized at MIT, and a pivotal experience in my own career. Witnessing professionals is a pun that works particularly well for me. I do have a sense of duty to become involved, to bear witness. In my 30s, I left theoretical physics and committed myself to a career devoted to understanding the implications of the big idea that ordinary activities of people could overwhelm this small planet. In college, I wanted to learn every big idea, and I had not heard this one. Like the ancient mariner, I feel possessed by that story, and I must tell it. I also am more of a witness than a participant in the development of climate change science. At the invitation of Michael Oppenheimer, I wrote a paper in Climatic Change, the journal he edits, with the title, Tell Us More. It is addressed to the authors about to write the IPCC's fifth assessment report, at the time when the fourth assessment report was winding up. And us, in Tell Us More, are the consumers of this report. Environmental leaders, business people, government staff, and the intellectually curious in all walks of life. In that paper, I was urging that the IPCC place less emphasis on reporting consensus and be more willing to display and explain disagreements. I witnessed not only the climate scientists, but also some of the communities trying to process climate science, notably environmental activists and scientists in other fields. I witnessed other witnesses. I bring to this talk a career that began in theoretical physics, where I saw science at its best. Openness and welcoming, contention and resolution, the Big Bang versus continuous creation, for example, error correction, the back of the envelope calculation, and especially meticulous attention to measures that would prevent putting a thumb on the scale, double-blind experiment and issues of that kind. Some of the best physicists in the world ushered me out of physics when I committed myself to the environment, and I took the norms of physics with me. Ever since, for almost 50 years, I've sought to develop tools that can help the conversation about sustainability. I keep asking where the conversation is stuck or is incomplete. Today I will highlight 3 parts of this climate story. All 3 make people uncomfortable. I feel empathy for those who resist acknowledging climate change. I am discouraged that climate science isn't yet valued sufficiently by the science community as a whole. And I am dismayed when people who have a favorite solution to climate change don't worry at all about advocates of other solutions carrying the day on behalf of dangerous solutions. So first, climate change resistance, then climate change science, then dangerous solutions. Climate change resistance. Humankind has discovered an unwelcome fact of existential significance. Our planet is small. Al Gore uses irony. It is an inconvenient truth. By our own actions, we can fish out the oceans, extinguish most of the species we share the planet with, raise sea level. It will take positive action to sustain ourselves. Not surprisingly, the message is resisted. It is not hard to empathize with this resistance. We wish we lived on a larger planet. People intuit that there are unappealing implications for consumption, for equity, for population size. Their resistance is similar to the resistance to Galileo's finding that we aren't at the center of anything cosmological, and Darwin's finding that we are part of a continuum of creatures. In all three cases, one finds derision and distancing. Galileo and Darwin knew the potency of their news. Is there a corresponding figure, be it a scientist or a theologian or a politician or someone in this room, who can communicate the new imperative of sustainability with a generosity of spirit? Right now, there seems to be a preference among environmental leaders and activist scientists for building a movement. And a movement, as Gus Speth explained to me, needs victims and villains. Might some socially engaged scientists lead the public conversation down other paths based on a search for common ground? Climate change science is undervalued. We could easily not have understood the climate change happening around us. Scientists organized themselves to study the planet coherently about 60 years ago. The International Geophysical Year was 1957-58 and spawned the first Antarctic ice cores. Charles David Keeling began measuring the CO2 concentration on Mauna Loa in 1958. We are deeply in the debt of the climate scientists, a few thousand people. Without them, we would be flying blind. But we rarely acknowledge this. Naomi is a student of this history, and she's speaking next. Why is there no advocacy for what I believe to be an imperative, a much larger global research program in climate science, and one that is risk-driven? The current one is not risk-driven. How quickly can things get bad? Which particularly bad outcomes actually can be ruled out? To reorient climate science is a task in itself, widely recognized but little implemented because of social norms within the scientific community that need to be better understood. Would risk-driven climate science be more broadly supported, leading to more satellites, more ocean buoys, tighter instrumentation of Antarctic ice, myriad studies of the tundra? Effective advocacy for, say, a five-fold expansion of global climate science would need to come from outside the climate science community. Today, advocacy for continuing climate observations, continuing today's climate science observations, is critical. In the news this week is that the Trump administration is suspending a satellite-based carbon inventory program. And yet I don't hear comments on it from the broader community. Such advocacy isn't even on the minds of the NGOs, as far as I can tell, the environmental NGOs, whose narrative is that climate change is settled. Portentously, raising the priority of climate change also isn't on the minds of the scientific leaders in other fields. Unfortunately, the politicization of climate change has made climate change science suspect in the minds of influential scientists in the two fields I know, physics and aerospace engineering. Assertions that 97% of climate scientists believe X, here X is climate change is caused by people, are counterproductive for that audience. Science isn't about believing, and it isn't about voting. Every good scientist leaves room for doubt. No other scientific field is shackled by anything resembling 97%, as far as I know. I sometimes think that I'm 97% sure that the dominant cause of climate change we have seen so far is human activity, and I'm leaving 3% for natural variability. The signal is gradually emerging from the noise. But I was at a meeting yesterday with an expert on climate change communication, who is Climate Central. Her name is Karen Fleury. And she made the point that nothing is as effective, as far as they can tell, in persuading people to take climate change seriously than the statement that 97% of climate scientists believe that climate change is real. The very statement that makes me cringe and makes the colleagues of mine that I want to bring along on this subject cringe is the one that is most effective in public communication. Respect for climate science is slowly increasing. I think it is partly generational. One of the reasons paradigm shift is because people die. Somebody said that. But it is important to take into account in today's discussion here what makes scientists in one field respect the science in another field. I think Naomi is going to disagree with that sentence. They'll say, just don't worry about it. Danger solutions, my third item. Melissa and Nancy have asked us to discuss, quote, the distinctive obligations, unquote, that we have by virtue of being people with special knowledge, again, quotes. Within this charge, Melissa and Nancy suggest that our special knowledge is about the concrete impacts of climate change on people's lives. I inserted two words into their sentence: the concrete impact of climate change and solutions on people's lives. I feel compelled to bear witness to the risks of solutions, as Robert J. Lifton did in his own tomorrow. I resist the entire framing that says we have a single overriding problem called climate change and that we must throw caution to the winds to solve it. Climate change is one of several big problems, and there are several ways of addressing climate change that could be cures worse than the disease. I have in mind nuclear power without strong international controls to prevent leakage into nuclear weapons programs and then nuclear war. Strategies that modify fractions of the Earth's land. Why privilege the atmosphere if you're going to wreck the biosphere? And manipulations of the stratosphere so that more sunlight is reflected. So-called geoengineering. All three solutions are in play. Regarding nuclear power, I quote for an article in Daedalus that I wrote with Alex Glasser, a professor here, called Balancing Risks, Nuclear Energy and Climate Change. We struggled to write this paragraph. Upper limits of climate change are terrifying, amounting to a loss of control of the climate system as positive feedbacks of various kinds set in. Nonetheless, at this moment, and conceding that such calculations can only embody the most subjective of considerations, we judge the hazard of aggressively pursuing a global expansion of nuclear power today to be worse than the hazard of slowing the attack on climate change by whatever increment such a caution entails. Don't get off the hook on this one. I too am dismayed that Jim Hansen has become an advocate for nuclear power. And we talked to him privately, colleagues of mine and myself. Nuclear weapons are more desired today than ever. And at the time that Alex and I wrote that paper included. Something we're doing right now in the U.S. has made them more desirable and makes this argument even more trenchant. And the geoengineering discussion, which is vexing in its own way, is imminent. There was a meeting devoted to that subject here on campus about a week ago with religious leaders who understand that they're going to be asked to come to terms with the deliberate modification of the planet for our convenience, as opposed to accidental, or I would argue exactly what deliberate means. I don't want to get into that now. So I have glommed onto a version of the Hippocratic Oath, a tribute to Louis Lasagna, which goes like this: I will apply for the benefit of the sick all measures that are required, avoiding the twin traps of overtreatment and therapeutic nihilism. Anyone who's had a very sick friend, a relative, or perhaps themselves, and has had to deal with whether to use a strong drug, knows this concept of the twin traps of overtreatment and therapeutic nihilism. This problem is not a simple one. Perhaps my story can help today's discussion. To summarize, I think scientists have a role in bringing about a less strident and more nuanced discussion that over time, perhaps a decade, will elicit the forceful action that most of you in this room and I would like to see. But I also know that nuance can obviate action. To me, an essential question for the engaged professional is how much complexity to reveal. Does candor build trust but delete commitment? I err in favor of candor, perhaps to a fault. There is so much to do, and I want us to ask why we aren't moving faster.
I think we'll have Naomi follow up, and then we have our discussion afterwards.
Oh, sorry, I thought we were having a discussion, so I don't have my computer turned on. Give me 1 minute. Do you want to take one? Oh, no, I got it. It's right here. Okay, thank you. Sorry. Well, thank you. I'm going to stay seated because of my condition of physical disability. I just wanted to start by reiterating what Robert just said about our other Robert. Oh, dear. Sorry. Let me turn this off. Many, many years ago, I read Robert J. Lifton's work on the Nazi doctors, and that work has always been an inspiration for me in thinking through these kinds of questions about scientists and how they think about their place in the world. So I wanted to take the opportunity to thank you for that. And your paper on the wedge solution to climate emission stabilization is something I've taught for many years, so it's an honor to be with both of you here today on this panel. I also just wanted to say something about my background because it's nice to be introduced as needing no introduction, but evidently I do. So I just want to be on the record as saying my original training is in earth science, and I do think it's relevant for the work I do. I trained as a geologist and a geochemist. I was a working geologist for a number of years before I went back to graduate school, where I retrained as a historian and philosopher of science. So you can decide for yourself what category you want to put that in. And then just one other comment in respect to Nancy's discussion. The whole thing about people becoming attacked is such an interesting, complicated thing because in my case, and I totally understand and sympathize with colleagues who get attacked and they just retreat. They just want to do their science and be left alone. But for me, it was emboldening because about 15 years ago, James Inhofe, who at the time nobody had heard of, accused me of being part of the liberal conspiracy to bring down global capitalism. And my response was, where is it? And when can I join? So, not really, just kidding. No, my real response was that liberals should be so organized. But the point is that there are different ways we can respond to external pressure. One way is to be frightened and intimidated, but the other is to look at what the situation is and to ask the question, why are we being pressured? And why are we being intimidated? And where is this coming from? And who are these people? And why would a senator from Oklahoma attack a scientist or historian, whatever you want to call me, from California, who wasn't even on the payroll of his state, because I had written a paper, which I guess Robert doesn't approve of, in which I analyzed the state of the scientific consensus on climate change, because I thought it was a relevant piece of information. And actually, the 97% number didn't come from me, but that's a different discussion. Anyway, so the point is there are different ways that we can respond. And what I've been interested in the last few years is to try to better understand why scientists respond the ways that they do, and in particular, to better understand why it's been so difficult for most of my scientific colleagues in the earth sciences to respond in efficacious ways. So I want to start with a little background. And the first one is to say, or to make the point, that I think scientists are different from other professionals, such as physicians, lawyers, engineers, psychologists, in a couple of important ways. And one of these ways is that these other professionals have clients. As a physician, you have patients. And you have recognized, and in many cases, stipulated ethical obligations to those clients. Those ethical obligations, in many cases, are linked to articulated professional codes of conduct, which under certain forms of public statements, or under which certain forms of public statements might be disallowed, or in other cases, perhaps obligatory. Now, often these codes of conduct are historically linked to professional licensing arrangements. I don't know that much about the history of medicine. I know more about the history of engineering. But in the formulation of these codes of practice associated with licensing, there typically have been public conversations about what the appropriate role of that professional should be. And a lawyer who violates those norms could be disbarred. A doctor could lose her license. An engineer could be decertified. Science is very different in a very significant way. First of all, we scientists don't really think of ourselves as having clients. And maybe partly for that reason, we have few, if any, formal codes of conduct that govern our behavior. And this, I think, actually leads us to be more sensitive to community norms of practice and more concerned about what our colleagues will think of us rather than what our obligations might be to our clients or to society as a whole. Now, scientists, of course, can be discredited, but there's no formal means to exclude, dishonor, or shame a scientist who has been misbehaved or construed to misbehave. So where do our norms come from? Well, we operate under community norms. And so I want to argue that in an odd way, this makes us actually more sensitive to community norms than other kinds of professionals, because it is really about what our colleagues think of us more than what society as a whole thinks. And in my work with Michael Oppenheimer, who unfortunately wasn't able to be here today, this is one of the things that we've found in speaking to scientists, that scientists are highly, highly attuned and highly sensitive to community norms and quite fearful of collegial censor. And we found that when we ask scientists about, particularly climate scientists, about their role in speaking in public, what they say most of the time is not, oh, the public won't believe me or I'll lose credibility with the public. What they fear is losing credibility with their colleagues. And this, we argue, has contributed to behavioral conservatism. Also, I want to note that, as I already mentioned, these licensing arrangements or practices that other professions have involve broader conversations with stakeholder groups. But scientists have largely in the past, with some notable exceptions, but have largely practiced really in isolation from other perspectives. And in my other major work that I've done in recent years on the history of Cold War Earth science, this really comes to the fore, where you see scientists who previously had broader engagements with what we could now call stakeholder community before World War II. After World War II, during the Cold War, these communities become much more what historian Paul Edwards would call closed worlds, where they're interacting with each other and with patrons who in most cases are in the armed forces, but have very little interaction with other kinds of community groups. And in my work in oceanography, I've shown how one way this way plays out is that oceanographers who are working on issues that today we would call environmental issues have no engagement whatsoever with environmental groups or even with marine biologists or cetacean biologists or coral reef people, even other scientists whose work might bear on the kinds of things they're doing. And so that kind of isolation strongly affects their thinking about who they're responsible to and who they have obligations to. And that has led, I think, most scientists coming out of the Cold War to have been very reluctant to speak out on climate change issues. And I think what we've seen in the last 20 years or so is a very gradual shift where someone like Jim Hansen, who was considered an extreme outlier when he testified in Congress in 1988, and I can remember colleagues in the School of Earth Sciences where I was at the time criticizing him for being too vocal, too public. And I think there's a historical reason for this that has a lot to do with climate science coming out of the Cold War environment. Now, as we know from Robert's own work and many other people, and I've also spoken about this in the public, it wasn't always this way. And scientists have a tendency to universalize what I would consider to be historically contingent norms. So many climate scientists, if you talk to them about this question, they will use historically transcendental language, as in scientists must not, or scientists must, or it's in the nature of science to. But of course, as a historian, I would argue that that's incorrect, that we see scientists doing different things at different times. So if we go back to the period that Robert has written about so much, the 1950s and early 60s, many nuclear physicists did speak out publicly in a very engaged way about the threat of nuclear holocaust. But that changed in the 1980s and 90s, and I think a lot of that has to change. That change had to do with the sort of funding structures that I just mentioned. It also had to do with increasing specialization of American scientists after World War II. Ironically, the rise of funding through agencies like the National Science Foundation, DARPA, and other organizations made scientists less dependent on the general public, more dependent on specific patrons, and shifted their sense of who it was they had an obligation to. So as I've already mentioned, scientists increasingly lived and worked in closed worlds. They had less interaction with general publics than they did before World War II. The Cold War also created a special kind of context in which speaking up about certain kinds of threats could be perceived as disloyal. And again, Robert's earlier comments about things like civil defense are a case in point. Many scientists in the Cold War came to feel that if they spoke up against American weapons programs of diverse kinds, that would be perceived as being disloyal to the American country, the American nation state. So the key point is that our views of the appropriate role of science and scientists are historically contingent, and we now live in a moment in which a new set of issues have come to the fore that have a kind of urgency that in some ways is similar to the nuclear threat, but in some ways has particular and distinctive characteristics of its own. And so that's a challenge for us to think about, because on the one hand, we can invoke the great physicists of the 1950s and 60s like Hans Bethe, Niels Bohr, Albert Einstein, Philip Morrison, wonderful physicists who spoke up and were very articulate spokespeople and who made a difference in the public conversation. But at the same time, the situation we're in today is not exactly the same, and it may require some different approaches. But nevertheless, it can change. So my argument then is that it should change, and that scientists do have an obligation greater than what most of my colleagues in neurosciences have generally acknowledged. And I want to say that that obligation is twofold. First, I want to say that actually we do have clients, and that our clients are the American people. That scientists have a general obligation to the society they serve, particularly when our research is taxpayer funded. And in the United States, that's almost all scientists work in academic life, as well as most of those working in national laboratories and federal agencies. And I think this obligation includes education and communication, which most scientists are reasonably comfortable with if they get the right institutional support. But I also want to argue there's a more specific obligation, and that is what I have called the sentinel obligation. And my argument goes like this. There are certain kinds of problems in the world that we would not even know about were it not for scientific expertise. So if you take the example of the ozone hole, if atmospheric chemists had not spoken up to alert us to the possibility that chlorinated fluorocarbons could deplete stratospheric ozone, we would never have known that that was the case. We would never have had the Montreal Protocol. And we can do a thought experiment. Fast forward 50 years from the Montreal Protocol, physicians like yourself notice that the rate of cataracts and skin cancer is skyrocketing, that certain plants were showing strange effects, that livestock were being affected, crop yield was falling, this set of quite alarming phenomena, and we would have no idea what it was. So a commission would be impaneled, or National Academy of Sciences committee, who would go back and they would dig through the scientific literature, and they would find, oh my goodness, in 1979, Sherwood Rowland, Mario Molina, and Paul Crutzen predicted this, but nobody knew, because they had just published it in a scientific journal, and like most science, it was ignored, and here we were 50 years later, and it would be too late to fix it. But that's not what happened, fortunately for all of us. They did speak out. They brought the issue to the attention of political leaders. They became public spokesmen. They became sentinels. They alerted us to the issue, and because we became aware of its severity, we acted. Now, many scientists I know will often use that as an example and say, well, we did it for ozone. Why can't we do the same thing for climate change? Obviously, there are reasons why climate change is bigger and more difficult than the ozone hole, but the example shows us the important role that scientists can play as sentinels. And you can all think of many other examples. Obviously, in public health, scientists have to alert us to impending epidemics, various other examples we can think of. So scientists need to be sentinels on emerging problems that ordinary people have no way of knowing would even be occurring. But that leads to a second possibility as well, which gets us into this issue of the solution space. And I totally agree with what Robert just said about the dangerous solutions. And this is where I think things get tricky, because once you become a public person speaking out on an issue, it is inevitably the case that if you speak to the public or you speak to journalists, the next question is, so what do we do about it? And there's an enormous temptation to want to answer that question, because there you are, you're being asked. And as a citizen, of course, you have opinions. And if you're a scientist, particularly if you're a physicist, I'm going to get that dig in, you probably think you know more than everybody else. You probably think that you're smarter about solutions than other people. I'm just teasing you.
I accept it.
Okay, thank you. But you know what I mean. It's not just physicists. There's a great temptation for any expert to be overconfident, right? We have lots of psychological evidence on this, to be overconfident about our knowledge and let that overconfidence spill over into other areas. And I do think that Jim Hansen is an exemplar of this dilemma, greatly to be praised for the role he plays as a sentinel, not so greatly to be praised for some of the recent things he said in the solution space, about which he's clearly less well informed. So my argument is what I call the argument of proximate expertise. As professionals, we have expertise. And that expertise makes us the right people to speak up on certain kinds of questions that are proximate to the things that we know the most about. And in some case, that might include solution space. So for example, as a geologist, I actually do think I have expertise to talk about carbon sequestration, because I know something about the problems of overpressuring of the subsurface. In fact, I know a lot more about that than most of my colleagues who are climate modelers. But I'm not an expert on legal solutions, not an expert on legal strategies, not an expert on the mental health effects of climate change. I'm not an expert about a lot of possible questions related to the solutions of climate change. Now, in some cases, as a historian, I may have some insights, but I think I have an obligation that is as great as my obligation to speak up as a witness. I also have an obligation to respect the expertise of colleagues in adjacent fields. So I want to argue that there's a kind of balancing act. Yes, we need to speak up, we need to be witnesses, but we need to do it based on our proximate expertise and with respect for colleagues in other domains. And so just to put that into practical terms, one of the things that was interesting for me when I first became a public voice on climate change was how quickly I was supposed to be an instant expert on everything. I'm sure other people in this room have had this experience. And fortunately, I was young enough and not egotistical enough to know that I didn't know a lot of things. So I started making phone calls to colleagues in other departments on campus, and I created a list that I kept on my phone: fisheries, John McGowan, ocean acidification, Antarctica, with the names and phone numbers of colleagues who were experts in those areas. Now, interestingly enough, I found that often journalists resisted that. Journalists were often in a hurry. I was the one in their Rolodex. But if you push back and say, look, I'm not an expert on ocean acidification, but my colleague, Richard Somerville, is, or whatever it is, then it begins to also give the message to the people you're speaking to that expertise is a complex thing. And if we really want to understand this problem, which is so multifaceted, we have to employ all the different forms of expertise that we have.
Maybe just sort of summarize some of the themes that I already see emerging in our discussion. And I think sort of one of our tasks today is to maybe generate lists about responsibilities for what, by what professional groups, but also responsibility to whom. And we already heard a variety of candidates for that. We have some responsibilities to the American public, as Naomi mentioned. We have some responsibilities in our own discipline, to be sentinels, both within the discipline and beyond. We also have responsibility to adjoining disciplines. And when I gave my facetious introduction to you two, I was alluding to this perceived hierarchy of disciplines within the space of climate change. The climate sciences basically sort of sit at the top of the hierarchy. And then we have to worry about the consequences of the climate system on the economy. And so the social sciences enter with the economists sitting on top of that sub-hierarchy. And then other social sciences, be it political science, be it psychology, be it sociology, sort of are at the bottom, maybe communication at the very bottom, the handmaidens that basically translate all the wisdom from this upper sciences down to the end users. And I think one thing that sort of we as scientists probably also have to fight is the miscomprehension about the nature of this enterprise. And if there's ever been a problem where we all disciplines, not just the social and physical sciences and climate sciences, but even the humanities and the professional disciplines have to contribute to climate change. As all of our speakers have said, there's no silver bullet. There's plenty of silver buckshot, but that buckshot needs to be applied in a very cooperative and coordinated fashion. And I think that's one responsibility we all bring to the table, is to figure out how to achieve that coordination, which is not easily done. And one of the reasons for despair, on the one hand, and we'll probably hear more about that later on, especially generational despair, I think, but then also denial or resistance, or reactance against climate change, is because people don't see solutions. They see a huge problem, and there doesn't seem to be any sort of easily implementable, feasible solution inside. And I think if we have any responsibility, we have to convince all of us from our discipline, the general public, and policymakers and businesses, that there are solutions, that solutions exist, and to figure out sort of how they can be implemented. So in terms of sort of other themes, I think with multiple audiences and multiple goals, there's tension between those goals. Yeah? And sometimes something that's a solution in one context, in terms of the nuclear domain, for example, might be not a solution in another context, which is CO2 emissions and climate change. And how do we deal with these risk kind of issues? So it's not just specialization within an issue, but also coordinating knowledge within disciplines or within different issues across the table. Generational issues probably will come up, and I agree that sort of learning by dying is a good way to learn. That's how we got from horses to cars. That's how we got from sailboats to steamships. The question is, do we have that luxury in the space where time is of the essence? So what we're doing today is influencing how 2 or 3 generations down the road will live. And is this a different issue because of the time urgency? And how do we overcome that? And are there other ways of learning, other ways of communicating and persuading that we might have to figure out more effectively? And then also, the other issue that I saw come up is this notion of complexity and uncertainty that exists, and how much of that to communicate, and is it overwhelming, or are we basically being paternalistic and actually doing ourselves a disservice by not sort of communicating that kind of uncertainty and complexity to people down the road. So on that, maybe I will open the floor for questions from this audience, because I'm sure you have plenty. Judy.
I wanted to give a perspective. Right now I'm a visiting fellow here at Princeton, but I've largely been a policy practitioner. And I was working for Congress in the late 80s, early 90s, in these early times of hearings on global warming. And one of my jobs was to pick witnesses. So I've been sort of thinking about this witnessing professional in that context. And at that time, and this is a little bit building on what Naomi said about people sticking to their expertise and how that, I think that is better. But it's really more about not so much the obligation, but what's effective. And our most effective witness at that time with the members of Congress was a guy named Rob can help me remember his name. I think his first name was Dan, his last name began with an A.
Dan
He's from
Albritton?
NOAA.
Dan Albritton?
Huh?
Dan Albritton?
Dan Albritton. And he used to have these, this is when we used to have transparencies and overhead projectors. And he had these handwritten transparencies and overhead projectors with overhead projector. And he used to walk through, this is what we know, and this is how we know it, and this is what we don't know. And this is what, and he would sort of apply where we were less certain. And he was a great teacher. And this was, to an extent this may be dated because congressmen now are much less willing to learn in public than they used to be. They're very, they don't want anybody to know that they don't know anything now. They're afraid that it's going to get caught on camera that they don't know something. But at that time, we really did use hearings largely to learn. And he was the best teacher. So I think somebody who can sort of take you through, explain not just a study. So I guess it's contradictory to this 97%, which I think is maybe more important for ordinary people than for the elites who feel like they're somehow obligated to understand something in behalf of their citizens, but sort of walking through this is what we know and this is how we know it, and not being asserting, but so much as educating. And that he was our most effective witness on the science. The other thing that we've learned since that time, and this is somewhat contradictory, is that if you only tell people about the problem but you don't tell them about the solutions, they tend to tune you out because they feel hopeless. But then you run into the problem Naomi pointed, if it's the same person, they're not generally not as expert on one side as the other. So we used to try to have both people explaining the problem who knew that part of it, and people explaining the solutions who would know that part of it. And then again, you get into people knowing different parts of this. You often need multiple people to tell you the whole story and make sure that you have it. But at least that's what I learned just in terms of the effectiveness side about what was most important. One other thing I want to mention, because maybe this is going to come up later and I have to come in and out a bit of this. So I was working at the Department of Energy most recently, and you may have read in the press that the transition team who came into the Department of Energy wanted a list of the people who had been working on climate. And this was actually quite, I mean, a little bit, may not be known, we actually had quite a discussion about what to do about that and did not provide the list. Of course, once the new administration came in, they could ask whoever they want about anything, but we felt it was very important to defend scientists against being sort of listed or targeted and sort of preventing. So I feel like there's also an obligation on the part of people who employ scientists or in a position to defend their independence, that's a really important obligation. Maybe not so much for this session, but for something to think about.
Can I respond? Sure. So, I would like to respond on the 97% thing, since I'm generally credited as being the person who started that whole line of research. Yes, so that's okay. It's not a problem. And you can't control your children. But so I wrote the original paper on the scientific consensus on climate change, and that was back in 2004. And the reason I did it was very specific. I had started recognizing what we now recognize as the network of climate change rejection. And what I observed were a number of things, but one of the things I observed was that the single most common strategy that they were using to discredit climate science was to say that there was no consensus among climate scientists, that we didn't really know, that there was a big debate. And I recognized that that was the same argument that the tobacco industry had previously used. Later, I was able to prove that that wasn't a coincidence, that the same people had been involved in developing these different strategies. But it seemed to me at the time important to refute that claim because I knew that it was false. And I knew it was false because I had been reading the IPCC reports, National Research Council, all the high-level stuff that had been written at the EPA, National Science Research Program, people like Dan Albrecht and stuff. But, so I had read all those reports. I knew that they were unambiguous in saying that there was a consensus among experts that the climate was changing and that most of the observed warming over the past 50 years is likely to have been due to the increase in greenhouse gas concentrations, right? That was seared in my brain like a mantra. It was like, rapping tefillin every morning, So, but what I wanted to get at was this question about the connection or the disconnection between what high-level scientific agencies were saying and rank-and-file scientists. Because every good social scientist knows that just because the leadership of an organization is something doesn't necessarily mean that the rank-and-file are on board. So I wanted to test that. And so I was trying to figure out how I could do that, and I had the idea that I could do that by reviewing the existing scientific literature using the Institute of Scientific Information database. And so I did this study, and it was very specific. It asked the question, how many published peer-reviewed scientific articles in scientific journals disagree with the finding of the U.S. National Research Council that most of the observed warming, blah, blah, blah. And the answer, I did a study, it was a sample of about 1,000 papers, and the answer was none. None, not any, 0. So I thought that was a pretty important finding, and I published it. And all I was trying to do was basically establish that, yes, the leadership of the scientific community says there's a consensus, and yes, that claim was consistent with what we could find in the peer-reviewed literature. And that was it. But I became the target of the climate denial machine, rejection, science denial, climate change denial, science rejection, whatever you want to call it. And it was that then led Senator Inhofe to attack me and for me to do all this additional work they ended up doing. But it was just a simple point. And subsequently other people followed up on it, and they had bigger samples, and with bigger samples they were able to refine it, and some used different methodological. And I don't think that literature is wrong or bad. The different numbers are to be expected somewhat because you use different methodological approaches, you'll get slightly different answers. But the important thing that we've learned since then is that it does matter to the general public. That the whole reason why the climate rejectors use the claim of no consensus is because their own market research, and this came out of the tobacco industry, showed that if the American people think that scientists are still arguing, then they think it's premature to have public policy. And when you think about it, that makes sense, right? If we really didn't know that climate change was a problem, then it wouldn't make sense to be having big, expensive policies to deal with it. But if we do know it's a problem, then it does make sense to do something about it. And this was exactly the insight that the tobacco industry had. If we didn't really know that cigarette smoking caused cancer and a host of other diseases, we might say to our patients, well, we're not sure, there's some evidence, you might want to think about quitting, but we wouldn't have the kind of organized public health response that we ultimately did have. So it's a totally rational thing But since we do know, the strategy of the rejectors is to try to challenge that and to try to make us think that we don't know. And that's why these studies are important. And there is social science research that shows that for ordinary people, knowing that there's a scientific consensus does in fact influence how they feel about the appropriateness of policy action. Now, it may well be that physicists and aerospace engineers are different than the general public. In fact, I think it's certain that they are. And so that leads back to what any communication person will tell you is a cardinal rule of communication, which is know your audience. You don't expect to make the same arguments with PhD physicists as you would make with the general public, and that's okay. So it just is a reminder to us that, you know, we need different strategies in different contexts. But for the general public at large, reminding the public that yes, scientists agree, scientists know this, we've known this for a long time, this is not news, and the people who tell you that they're arguing are the same people who told us that tobacco didn't cause cancer. That does turn out to be very effective with many people.
I think we want more questions. I'm going to wait till later.
Okay, then
but
Jessica's next.
I'm Jessica Green. Thanks. This has been just fantastic discussion, and I just wanted to make a couple of quick comments to sort of throw into the hopper. I was really struck by the distinction you made, Rob, between the tension between nuance and how conveying nuance may constrain action. And I think this is really important. One thing that I've thought about in my own work is the difference between, the political differences between risk and uncertainty, right? So risk where we know the distribution, the probability distribution, right, more or less, and uncertainty where we really don't. And I think that this is actually an important thing. You know, this is part of what the IPCC does. We have high confidence, medium confidence, whatever. But this might be a way to think about how do we deal with this tension between conveying nuance and the possible constraints on action when we are public-facing in our work. The other thing I wanted to talk about quickly, respond to was Elke's sort of list of to whom do we have responsibilities as professionals. And I would also add that we have responsibilities towards students. And I think that this is really important for a number of reasons. First, because it keeps us honest in our work, I find. It helps us refine our communication skills. And I think it can help with thinking about a risk-driven agenda, right? Which was also very appealing to me, right? Is that students want to, whether they be undergraduates or graduate students or postdocs, whatever, participate in thinking about how do we craft solutions, and I think this is a really important way to both engage them and build future witnesses, right? And so if we think about this problem of witnessing as at what scale are we trying to organize action, right? So we talk about the nation state, the species. This is a very important one that I think can have potentially have sort of multiplier effects that are really important.
Should we take a few comments and then
Yeah,
respond?
yeah, no,
So
let's do
Katrina,
that.
I think, was next. Katrina?
So I was going to jump in on the 97%, and I hear what Robert is saying about it's not particularly compelling if you're coming at this as a scientist. But I would agree with Naomi. It seems highly publicly effective. And one concern I would raise as we're thinking about the balance between nuance and action is that to be mindful of the public to hear consensus and not to realize we're talking about consensus with respect to some narrow bands related to mitigation and anthropogenic influence. And there is, I think, a significant delta in terms of where we are in terms of those basic mitigation facts and where we are in terms of understanding, projecting how climate change will manifest in particular locations. But I think that gets obscured for the public, and it strikes me that there are two possible dangers there. One is to lead to a malignant normalization of our hubris about our ability to predict and understand how this will manifest. And then a second, that it seems to be one core value we need to have that I think, Naomi, you were getting at in talking about our respect for other professionals and understanding what the narrow scope of our expertise is that it needs to be a core value to preserve our claim to expertise. And when we have projections about the impacts of climate change that are out there under the veil, under the umbrella in the public's mind of the consensus, scientific consensus about climate change, that when those projections turn out not to manifest or not to come out the way because they're not as certain, and there are a lot of other, they're not under that veil, that then raises the risk to call into question our claim to expertise. So those are two dangers that come to mind.
Were you going to say something, Harold?
First of all, with respect to the last couple of comments, but I had to wish for one thing regarding our relationship, the relationship to scholarship to the public. I'd wish for people to be able to distinguish between not knowing everything and knowing something. I mean, very often these things are really confused because we don't know anything. It's as if we know nothing. And that is something, if some of you have any ideas how we can straighten that out in the public's mind, that would not resolve a lot of problems, but it would certainly be helpful. I wanted to go back to, if I could, to the witnessing professionals and so on. Some professionals have codes and some don't. I've got very ambivalent feelings towards professional codes because they're more often self-serving than they are serving the public, broadly speaking. So I'm not so sure I want to follow the medical codes, legal codes, and all those that govern professional behavior so easily. And we have to think, I think we have to think more broadly. I'm in favor of having some kind of ethical responsibilities, but I think we have to think more broadly and maybe not use the codes that exist as a way to get started or even as a model. I think we need something broader than that. We can't get away from, just as I mentioned before, we can't get away from the fact currently when we have nations, we also can't get away from the fact that we have a social division of labor in this country, or any country, or any advanced country. And we have to take that into consideration. We can't be everything. Okay? None of us can be everything. And we have to really build trust between the people in various parts of the social division of labor that we have. And I don't think there's any alternative to that. And it might be interesting if any of you here have some ideas how we go about that. Well, witnessing professionals help us build trust across the social division of labor that inevitably characterizes our society. I think we can't get around it. And so I'd just be interested if people have ideas on how we could generate that trust. Because I think if we can't do that, it won't work in the end.
This might be enough so to maybe get some responses from you.
Okay. One puzzle is why, Harold, we have so much difficulty with communicating. We know something and not other things. When we have a weather report that tells us there's a 70% chance of rain, and we take our umbrella, it's 20%, maybe we don't. And we have this kind of information that there was a particular individual who decided, his name was Bob White, that the weather Bureau should use percents. I gathered in some countries they still don't. Talk about uncertainty that way. So we're surrounded by uncertainty, and yet we have problems with this one. This 97% is particularly well known, Naomi, but I was part of a less public, but out in the public conversation within the physics professional society around the word incontrovertible, which some of you know, I think probably you do, Naomi, but the physicists in their own way have a statement, a catalog set of statements on public issues, and they have one on climate change, and it was developed by a committee, and it chose to say that the climate change, the explanation for climate, I think it was anthropogenic climate change is incontrovertible. And if any word could be chosen as a red flag for scientists, it's that something cannot be countered, right? It cannot be, nothing could happen that would make it wrong. That just isn't in the canon. And it's in the other canon. So it became a public argument, and we had another round. I was actually the head of the panel on public affairs of American Physical Society through a period. I was asked to step down because I was prejudiced, and I refused, or didn't see why I should be recusing myself. We were going through the subject. And I watched, and the thing about climate denial, some people out there in front, but I guess the message I'm bringing is there are thousands of people in the sciences who are uncomfortable with the way climate science is perceived. But uncomfortable with the way they perceive what's going on. You have young people discouraged from going into such a a politically fraught subject. Do something else that's less in the limelight. You have, and I'm really going to say it again, the fact that we're canceling measurement programs right now and not getting a peep out of anybody is really, we have to do more climate science. Because we really don't know how bad it will be, and we need the earliest warning we can. And yet we're not internalizing that. And it's, I'm talking for the climate professionals, I think. They need advocates within the science community, and they're not getting them. And what I hear then is therefore a collision between, you can't compartmentalize the conversation with the public where you talk about 97%, and the conversation with the science community as a whole, the National Academy, wherever, where you don't. So, because it's a single arena, you can, and that makes it harder.
Do you think that's sort of tied up to Harold's other point about the codes of conduct, the professional codes of conduct, and scientists thinking that ought to be above politics? And
I don't hear above politics, but
well, you talk about politically fraught.
Yeah, well, the advice to young people is politically fraught. That is about the politics. Yes.
Can I just quickly respond? I wanted to respond to two things. One thing that Katrina said about being clear about what the 97% is about. I mean, I think this is one of the challenges of being in public, because in my scholarly work, I am excruciatingly clear about this issue. And in my, what I thought was a famous paper, but obviously not as famous as I thought it was, it's very cited, I actually am excruciatingly clear about exactly what it is that's being tested. You know, the hypothesis is, the question is, how many papers disagree with the statement. And I even have a section of paper where I explicitly say, this is agreement about, the question was whether or not observed warming was likely to have been due to the increase in greenhouse gas concentrations. That was it. And I even specifically had a section in which I said, this does not tell us what will happen in the future. In fact, if you look at the literature, that's where the big debate was going on at that moment, right? Not about whether climate change was happening, but what it meant for the future. And I even made an explicit analogy with the history of evolution, where in the 1930s there's a famous argument in the history of evolution that some people here may know about tempo and mode. Nobody disagreed that evolution occurred, but there were big arguments about how it happened and how quickly. So I was excruciatingly careful about that, and in my public work, I think I have continued to be careful about that. But, you know, my most recent book has on its front cover a message in a bottle, because one of the things I've learned about being a public figure is it's like a message in a bottle. You send out your message, but you don't know who will pick it up, and you don't know how they'll read it and what they'll say with it. And that's just a challenge that I think we have to accept and continue to think about what we do with it. I also wanted to respond to something that Harold said, because I think your point is an extremely important one about the division of labor. I think that there's no question that a lot of the power of contemporary science comes from specialization, division of labor. And we would be hard-pressed to argue in many areas that that was a bad thing. And yet, I also think it's one of the reasons we're having so much difficulty with the issue of climate change, because it is so multifaceted, and because the impact, the facts of climate change, the impacts on people, the solutions, all require very diverse forms of expertise to address. And we aren't very good in academic life in bringing those things together in a respectful and collegial way. So if there were one thing I could wish for, it would be that we would actually think through that problem in a more serious way. And also, one other thing I want to say, one of the questions that's always been informing my work is the question of why this is such a particular problem here in the United States, when it's not much of a problem in Germany, France, England, Italy, other countries that we might think are similar to us in certain respects. And I think the answer to that is also complex and multifaceted, but clearly one element of it is American individualism. And because we're really now saying we have to work together as a team on this problem. And I think it's one reason, I mean, people here who have been involved in the IPCC know this. In my experience, our European colleagues are a lot more comfortable with the structure of the IPCC. European scientists, in my experience, are very engaged with IPCC and tend to be less critical of it than American scientists are. And, you know, that's complicated as well. So I think thinking through this question of individualism and how it plays through our academic work, our social work, our public witnessing, is a key part of figuring out how we address this problem in its full complexity.
I just want to make sure for one moment that the issue of 97%, as I see it, is on the table, which is I've got to find the other 3% and talk to them. That is what the scientist hears. And Naomi's example before of Sherry Rowland and Mario Molina, they were maligned by the chemistry industry, they're maligned by the chemists, the chemical society, and they got a Nobel Prize because science is about rewarding the person who, when they see something that's not supposed to be there, a pulsar in astronomy, they don't put it aside and say, I must be wrong. They push it until they see what's going on. Rowland asked, this chemical doesn't seem to be destroyed. It's so strongly self-contained in the atmosphere, it's not attacked until it gets up to the stratosphere, to the ultraviolet, which is the one thing that's strong enough to break it down. Wow. And then they kept saying, well, maybe something else breaks it down. So this is the virtue in science, and it's the very virtue that 97% makes clear that somebody says that doesn't know how it affects the science community, or at least it affects the science community in the opposite way. We've said it a few times.
Yeah, but I don't want us to get bogged down in this because it's really a small point relative to the topic, but it's important, I think, as a historian, for me to challenge you a little bit on this for two reasons. First of all, in any scientific community, there are always people who disagree, and that's just going to be how it is. And we can find people who don't believe in plate tectonics. We can find people in your own community, physicists, who don't believe in quantum mechanics or relativity, and that's fine, and we should treat those people with respect. But it doesn't mean we should be basing public policy on those people, right? If we based public policy on people who rejected plate tectonics, we would not have adequate earthquake safety in California. So it's really important to make that distinction. The other important point is that these things have to be viewed historically, because it's very different to have an idea that is disturbing or startling or surprising before a question has really been looked at closely. And so the example you give of Sherry Rowland and his colleagues, and this is in the book, shameless plug, but Michael Oppenheimer and I and other colleagues have a book coming out where we have a whole chapter on exactly this question, because it is so important. So if somebody hasn't studied something, and somebody comes along and they have a surprising idea, and they say, hey, we haven't looked at this, and we really need to look at the problem of lemons in a water bottle. Like, how did you get that lemon in there? Then that is saying that, yes, we have to be open to the possibility that something we didn't think was important might turn out to be. But I have to say that that's different than the phenomenon of, we've now been studying this thing for 50 years. Thousands of very talented scientists, well-funded, have looked at this from a tremendous number of different angles. And there are still some people who, for whatever reason, disagree. Well, okay, fine. I studied people like that. My first book was on the history of continental drift and plate tectonics. One of the world's most famous geophysicists, Sir Harold Jeffreys, one of the founders of Bayesian statistics, a brilliant man, went to his grave rejecting plate tectonic theory. Okay, that's life. But it doesn't mean that I should be spending too much time worrying about Sir Harold or reject plate tectonics because of that. And especially if I have to make public policy, I keep an open mind. In the back of my mind, there's always that idea, yeah, there could be something. And for me, the 3% in climate change, it's not the people that are the thing that are a concern, in my opinion. It's that, yes, there could be something in the system, some phenomenon that we don't understand, that we don't know about, that we haven't really grappled with, that we think isn't important, like the heterogeneous reactions in CFC depletion, that could turn out to be important. So we have to be open-minded to that. And that's the most persuasive argument, I think, for why we have to keep doing science. Because there's always this possibility that we'll discover something new we didn't expect. But it doesn't mean that from a public policy standpoint, we should be, so I'm going to use an Australianism here, but I can't think of any better one. We shouldn't be getting our knickers in a twist just because there's some old guys out there who aren't on board. Sorry.
So I think we put this argument to rest for now. And it does relate to the multiple goals that we have for science as well. But I think we have ignored this side of the room. So Melissa first, and then we move down.
Thank you. So I wanted to pick up on Naomi's point about our theories of communication say you have to know your audience, because I think actually one of the major problems that we're facing is the problem of nothing nowadays can be said only to one audience. Anything that's said to one audience can be overheard, cherry-picked, misconstrued. Now, that's in a way your message in a bottle point, but I actually think it's a really fundamental challenge for our theories of communication, that in a way they're so focused on knowing your audience, tailoring to your audience, and yet the whole problem now, which gives us the nuance versus action and the kind of misunderstanding. So I really think it's a call, to Elke's discipline and others. How do we have a theory of a communication in a world where audiences are systematically uncontrollable and untargetable in that sense, because anything you target can be. So that, I wanted to also just go back to the original historical question of that Robert raised about the origins of professions, and just put in a thought from my own current research on Greek philosophy, which may sound completely unrelated, but actually with a graduate student here. So what her work is showing, Emily Holm-Cozy, is that the Greeks did think that there could be neutral techne. So a techne, a sort of technical expertise, could be neutral. You could have a bad techne, a techne of piracy or something like that. It could be morally neutral or even bad. But the techni that were caretaking, that were caring for others, those had a kind of intrinsic moral purpose. So if you're caring for humans or animals, which were the examples, medicine or cow herding or something like that, there you have a sort of implicit moral focus. And I think that actually, to me, that's actually quite a helpful thought, that we have to articulate that. But I think finally, to bring it back to Naomi's presentation, the question I think that raises for the natural sciences and the sciences of climate change are, can one say research on natural Earth systems has an implicit caretaking dimension? It's not simply neutral, because in doing that research, we're not only seeking to understand reality, we're also seeking to understand risks, inevitably, to kind of human and other species, as Robert was saying. So to me, that's a real question about the implicit purposes of all scientific research that needs to be addressed.
Let's move down.
I'm Bill Blakemore. I'm a professional journalist. And since 2004, I've been focusing on global warming when I discovered gravity, which we heard about for 30 years. The reason I'm proud to call myself a professional journalist, and am one, is because early in my career, I don't even like that word, I met Michael Schudson at Columbia University, who pointed out, he was the leader and still is the leader in pointing out that journalist is a word which, until about 90 years ago, meant propagandist. You expected to be a propagandist and expected yourself to be a propagandist, you were called a journalist. But he pointed out that the profession of journalism only got started in about 1920, roughly. And I believe that's because it's only then that Karl Popper and Peter Bryan Medawar began to clarify the philosophy of science. That they pointed out that the inductive fallacy is wrong, that hypotheses come from everywhere, and the important question was how do you decide a good quality hypothesis? And he pointed out, Popper and Medawar did, that a good quality hypothesis is high risk in two ways. It's refutable, clearly stated, we journalists call that, you check it out, and it predicts things that you didn't think could be predicted, we journalists call that news. And so I am not the media, I am not the press, I'm not a communications expert, I don't deal in communication theory, I'm a professional journalist. The way I divide it up is I talk about the science of journalism, the art of the story. To us journalists, professional journalists, story is a term of art. And we say, is this a story or not? What makes it important? And that's very central to our problem here. A couple of terminology points, speaking directly to your question about nations. Climate change is a term that was promoted and is still promoted by a fossil fuel industry hired propagandist named Frank Luntz. He recommended that they don't use the word global warming. Too frightening, too real. Climate change is more fuzzy. And I hate to use the word climate change for that reason. It's not international warming, it's global warming. And global is a new idea that's coming to amazing new realization for all of us because of the World Wide Web as well, which is the coincidental grid news. But it's the global warming because two massive borderless systems that sustain life have no borders, the swirling atmosphere and the swirling ocean. It's global warming, not international warming. So as a journalist, I realized that one of the problems is how to describe the overall problem, how to get your arms around the problem. That's one of the things people look at journalists to report what's going on. I call that now the enormity problem of journalism, the enormity problem of global warming. There's been an evolution in the talks I give about this. When I first discovered the gravity of the problem, I called it the basics of global warming, and then I turned to the many psychologies of global warming, which is about 59 basic psychological aspects of the story. Now I call my talk the enormity problem and conceivable hope in global warming. I used to call it plausible hope. I don't believe in that anymore. Realistic hope, I don't believe in that. Conceivable hope. And there is conceivable hope in such things as Klaus Lochner's free air capture, which is possibly not geoengineering, but just cleanup in a certain way. And the challenge now is for, well, the reason I'm not the media, although it's an important distinction to make, is where this is all happening at the same time that the one world communication is happening. Anybody, because the World Wide Web, can get their own blog, and if they're really convincing, they can be understood all over the world. And with the help of Siri, you can plug in a pretty good computer translator, so you can talk to anybody in the world about what psychologists are finding about our weaknesses as a species. Interesting point about species size, and the fact that we now must become species sensitive, which Robert has led us to think about. It's interesting to think about why we don't care about a species as much as we do about our family, our group, our local group. It's more intellectual to worry about a species disappearing, because you don't have we can understand it intellectually, but not quite so closely. Emotionally, we care emotionally about people who are closer to this distinction. And finally, let me just say that at the moment, when I was challenged recently to describe a situation, what's the basic known situation? Well, I use the graph that shows ice house, greenhouse, Earth, because people confuse ice house with ice age. This is ice house Earth outside, and we are now artificially kickstarting ice house Earth straight back up into greenhouse Earth, which is, we're very happy. And it has gone before, but it's always gone over millions of years. We're doing it in 2 decades. And that means, final description, I'm sorry, but we have to accept this reality, I believe. And journalists haven't just admitted to themselves, because we're all afraid of death. I mean, a woman recently said, why don't people accept journalism, accept the reality of man and global warming? And I realized it's because she said people are afraid of death.
Bill, I think we want to move on to
Right.
it. Yeah.
So the final thought is, it's uncontrolled already. The only remaining question is whether it's controllable. It's already self-sustaining, but it's hard to admit how that's already uncontrolled. If we do nothing, it reinforces itself. The remaining hope is that it's controllable. Distinction. Right.
Sam had a question for that.
Robert introduced the notion of topics. Robert introduced the notion of topics being politically fraught, and I just wanted to expand on that just for a second as a note of caution on effectiveness of scientists directing their message to what's politically palatable at any given point. There's a huge correspondence in public view. Those people who are skeptical of climate science also believe in the importance of gun ownership. They believe in threats posed by immigration, antagonism toward the United Nations, the destruction of our national character by the direct election of senators. There's a whole series of beliefs that correspond to a sense of political orientation in the United States, and that we happen to be living in a highly polarized age. The idea that climate science is likely to be a wedge issue in this set of beliefs is a testable proposition. I am skeptical on that proposition. If that is a concern, or if I'm correct on that, what follows is that tempering the level of the scientific debate to achieve a 97% consensus or whatever level of consensus, because that seems to be more forceful in a Senate subcommittee hearing that nobody has their minds changed by at all, is not an advance in my view. And it should be a note of caution and internal self-censorship by certain communities, because they want to be helpful in the political domain. And the only note of caution is it's an empirical question how effective these communities actually are in the political domain.
So maybe we'll get some
Yeah,
responses.
can I have a quick question on that? I'm not quite sure I understood. Were you saying you think it is a testable proposition, or you think it's not a testable proposition?
Oh, it is a testable
Yeah,
proposition,
okay.
whether
Yes.
saying 97 versus 92 versus 100
Got it, okay.
would have any palpable
Yes,
effect
so-
either on the debates within the Senate subcommittee or on broader perceptions.
Okay, so though there is information on that, it is a testable proposition, and in fact, it has been tested in certain circumstances. So the testing that we know that has taken place involves, quote, the general public, focus groups, that sort of thing. And among the general public, it strengthens support for climate action if people are given information that makes a credible case that there's general agreement in the scientific community. So we do know that. Whether that's effective with this in the Senate is, in my opinion, a different question. When it comes to the political alignment, we also have a tremendous amount of information about the political alignments, and there's strong alignments with republicanism in general. Climate change rejection is much more common among Republicans than Democrats or Independents, and particularly strong alignment with what we could call the far right of the Republican Party. And one reason I know this is because when I was doing my own work on climate change, denial and rejection, I'll call it skepticism, denial, and rejection, because I think there's actually a spectrum of how people respond. One of the things I found was that some of these websites also advocated the return of the gold standard. And that, for me, now this is now going back 15 years, was a little mystifying. I'm like, what does climate change have to do with the gold standard? But actually, once you understand it, it makes total sense. It has to do with restraining government, because the common theme in many of these things is a certain notion of individual liberty tied to the concept of limited governance, and that also then helps explain the alignment with a certain way of thinking in, an element of the Republican Party. So we actually have there's a lot of research on this. It's pretty well documented.
I think the one that I've seen, because part of my focus is where I overlap with Nancy's focus on political parties and institutional structures of politics, is that it helps mobilize people who have already committed in one side of the debate, the ability to shift the debate. And given the Republican control of both the Congress and the presidency, through greater levels of scientific consensus, I think is remote.
Yes, last word.
Is remote.
Remarkable. There's been one very patient hand, and you get the last word in the session.
Thank you. My name is Oreskes. I'm a physician and research scholar here at the Oreskes School. I work on biodefense, public health, and food security. One group of scientists that I think are being ignored are the agricultural scientists. Let's not forget that agriculture is the foundation of civilization, and the fact that for the past 10,000 years, the climate has been remarkably stable, relatively predictable, allowing farmers to know when to plant their seeds and when to harvest. So they are the most dependent on an amenable climate to the production of our food. Farmers and the agricultural scientists should be involved in these discussions because everyone should care about their food supply. I would just like to point out the work of one plant biologist, geneticist, Dr. Joanne Shorey, who works at the Salk Institute in La Jolla, California. According to Dr. Shorey, plants fix about 860 gigatons of carbon dioxide from the atmosphere. Unfortunately, much of that is then re-released when the plants are harvested. Plants make a compound called suberin, which is a cork, basically, around their roots. And what she hopes to do is genetically develop a plant that will have deep roots, a perennial, deep roots with this compound around it to fix carbon dioxide for hundreds, if not thousands of years. And this would effectively address much of the excess carbon dioxide in the planet. The challenge, though, and of course there's always a kicker, is to appease anti-GMO activists. She's going to try and do it the old-fashioned way through crossbreeding, which will take about 10 years. And according to Dr. Lynn Blue, who I heard speak last month, we're going to be hitting the conditions for 2 degrees warming in just a few years. It's happening much faster than we thought. At 2-degree warming or 3-degree warming, much of the planet is going to become too hot and too dry for agriculture, meaning that you're going to have billions of people leaving their homes looking for more habitable climates. I would argue that it would be much faster to use more advanced technologies like CRISPR to genetically engineer a plant because we don't have that much time.
I think we need to wrap things up, Laura.
What's that?
We need to wrap things up.
Yes,
The session's
I'm
going.
wrapping it up right now. because of our largely scientifically illiterate society, we've been hamstrung by our best efforts to address climate change. And really education and getting these scientists, like the anthropologist, out to the public to communicate with them, I think should be a priority.
It's very much a contribution to this notion of risk analysis. What is considered a problem in one domain might be a solution in another domain. You going to say one final thing?
Yeah, because I heard you say something very important in terms of what was testable, which was whether climate change could turn into a wedge issue in the sense of, or a binding issue between the Republicans and the Democrats, separable from issues like guns and abortion. I think that is exactly where I'm coming from, that we want to test whether Republican elites, like the senators, can be peeled off because the argument presented in more gentle terms that we are changing the planet and we wish it were bigger and things like that, not about science consensus, I don't think it has much to do with this part, can actually bring people on board. We need safer spaces for the communications, and the stridency is not going to work. Both Elke and I heard this guy at the Wisconsin Center, who was working at this specifically, and I find it very compelling. I don't think we have to give up on that.
Back to you, Nancy.
No, we have a coffee break.